This is a special time because it's our last exercise set in our M105M course, Section 6 of Module 6. So what we'll ask you to do, and I think we have this big, let's see if I can make it a little bigger. And it all fits, there we go. This is our last matching. So we may give assignments or ask you all to do it. 1 through 8 items are only used once. So we'll pause. Now here, the key thing is, what would the next step be? So in looking at this, and you want to solve for this exponent, you would just change this to its log form, which is this down here, and then the step to solve it, they're not asking you for that, but you would take the x, put it in front over here. This x is now gone, and now you divide both sides by the log of 5, and that'll give you x, and you can put that in your calculator and you'll find out what x is. So again, they're showing you the next step. Now in number 2, notice e is our natural log, so we would convert this to a natural log setting, and again we're going to take the 5x, put that in front, and divide both sides by the natural log of e, and then continue. But they're just asking for the next step. In letter F, natural log of x equals 3. So what you might do then is convert this to its exponential form, where natural log is e, this is the exponent, and that equals x. Now if you put the natural log in your calculator, raise it to the 3rd power, that would give you what x is. In this one, let's take a look at it. Log of base x to the 5th, or of 5, equals 3. So just converting that from its logarithmic form to its exponential form. Letter B, here we see something in where there's a plus. We know there's going to be this multiplied by this. So going to be, so when you multiply x times x, you get x squared. And then x times negative 2 gives you a negative 2x, and that equals 3. So that would be the next step. And some of these are challenging. In letter D, that we see there's a negative here. We know that we're going to be dividing something. So the only ones are, let's see, there's G and D, and this looks like D right there. So this is in the numerator, this is in our denominator, and it equals that. Okay. Now in letter G, they are dealing with natural logs. So instead of using log, we use the natural log symbol, and it's a similar process. And then our last one, letter H, this would be multiplication. So x x equals 3, up here c. Okay, now we had another one like that, didn't we? Oh, the difference between these two. Here the base is 5. This would be your common logarithm of 10. Again, we don't write it. All right, so rather challenging, but what you'll need to be able to solve logarithmic equations, and keeping in mind that they can be converted to their exponential form, and a number of techniques we've worked on to get these solved. Let's see what else we could do. All right, well, let's do 9 through 14. I think each table can have one to work on. We're looking for the next step, and then if you can solve it, good. Some you would need a calculator for. So let's pause. I'll do these live with you so we can see the process. So there's the equation, and we know we have 3 to the 2x equals. Now, when I see my base here of 3, can we get a base here that has 3 in there raised to some power? Well, yes, that is 3 to the 4th power. So we now have our bases equal to each other, so therefore our exponents equal each other. So we go 2x equals 4, and we say x then equals 2. So if x is 2, 2 times 2 is 4, 3 to the 4th power is 81. So that checks out nicely. All right, we're going to do the same thing with number 10. We have 2 to the 3x power. Now we're looking for some value of 2 to what power is 64. Now I believe it is 6. 2 to the 6th power is 64. So this is done in a very similar way. If we have our bases equal, we then say our exponents are equal. 3x equals 6, x equals 2. So 3 times 2 is 6, 2 to the 6th power is 64, and this one checks. All right, now when we get to 11, we find that there is no value of 32 that would have a base of 4, so we can't use that technique. So we use the change of base formula, in a sense. We're going to take the log of 4, and that would be to the x power. We take the x, put it in front, and we take the log of 32. So this is our next step. Now how do we get our answer? How do we get x by itself? Well, we're going to divide both sides by the log of 4. When you put that into your calculator, it comes out 2.5. So you might try it. Put 4 caret 2.5, and that gives you 32. I tried it on my calculator and it works. All right, let's take a look at the next one, which is going to be very similar, I'm sure. Again, there's 3 times 3, which is 9, but no. So you're going to have to use that formula. So x, the log of 9, just changing this to its log form, taking the x, putting it in front, a technique we learned earlier, equals the log of 27. Divide both sides by the log of 9, and we get x equals 1.5. Again, I had to use my calculator, and if you try this, 9 to the 1.5 exponent in your calculator, caret that, it is 27. And this is the way to use logs to find our answer. And these last few are done exactly the same way. So now that you have a way to do it, you can just write it out. It's going to be x log of 2 equals log of 10. Divide both sides by the log of 2, and that will, now here these don't come out evenly, you have to round it to 4 decimal places. This one is done the same way, so you can actually maybe jump to this step. X is going to be what? Log of 24 divided by the log of 2. So this would be 4.58496. Now since this is a 6 and we're rounding to 4 decimal places, this then becomes a 10, this becomes a 5. So our answer then is 4.5850 approximate. Okay, you'll have some to do for your practice quiz me, and you're getting ready for your Module 6 test and your exit exam. And good luck to all of you.